So for our first optimization problem, we're going to do the one that's usually the first optimization problem, which is the farmer problem. Many of you have seen a version of this in pre-calc class. So the idea is that we're going to solve it in a calculus sort of way instead of the pre-calc way. I'll explain in a minute what that means. Um, so we have here a farmer. A farmer has 120 feet of fence and wants to build a rectangular pig pen next to a river. And we're going to assume that pigs can't swim, so the farmer doesn't need to fence the side that abuts the river. So the question is, what dimensions, length by width, will produce the pen with the largest area, given, of course, that the farmer only has 120 feet of fence. So first of all, what we want to do is we want to ask, what is the quantity to be optimized? The reason we're asking this is that that quantity, we're going to try to write that quantity as a function of something else, and that's going to become the objective function. So the quantity to be optimized is the area of the pen. Now now that we know what the quantity to be optimized is, what we want to do is write, oops, that's not the word write the area of the pen as a function of another variable. This is, of course, the thing that where people are going to get stuck is what is the other variable in the problem. I think it becomes apparent once you draw a picture. What we have here is we have the river, and we're trying to build this three-sided rectangular pen, right, rectangular enclosure. So the easiest way to do this is we're going to label one dimension of this rectangle. I'm going to put the x here just because it comes out a little more convenient if I do. I know that usually we put x on the horizontal, but I'm just going to say that x is that dimension of the rectangle. Now, I can call this y, but that's sort of beside the point. One thing about optimization in this class is this course is called single variable calculus. There are tools to analyze functions of more than one variable, but we don't have them yet. You're not going to get to those until you get to calculus 3. What that means is that I can't just say that the area of the pen is x times y. I need to write every objective function in terms of one variable. If you ever find that you have two variables in the objective function, it's the wrong objective function. We don't have the tools yet to analyze a two-variable function. So I need to pick one of these variables. That's one of the reasons I put x on the vertical here, is because I'm going to choose x as the variable, and it'll just look a little cleaner if I do. So, what I want to be able to do is rewrite y in terms of x. So we know that there are only 120 feet of fence. What that means is that if I'm going to use up all 120 feet of fence, then y has to be equal to 120 minus the only other two places where fence gets used up. In other words, I use up some of the fence, some of the fence gets used up here on that side, and some of the fence gets used up here on that side. By the time I'm done with that, I've used up 2x length of fence. So that means that we can write the area in the following way. We can write that the area as a function of x is just going to be x times 120 minus 2x. That equals 120x, not 12x, 120x minus 2x squared. So there's our objective function. I'm just going to write that this is the objective function. And that makes sense because that's what an objective function is. The objective function always gives you the quantity to be optimized, and it does so as a function of some other variable that we can define in the problem. So 3, we want to ask what the domain is. Now, certainly a of x is defined everywhere, but that's not really the point. The point is that if I had to ask what the smallest possible value of x can be that makes sense in this problem, certainly that's going to be 0. In other words, I can't have a pen that has the vertical dimension any less than 0. 0 itself doesn't make a lot of sense. It would give us a pen of 0 area, which certainly doesn't fulfill the goal of giving the pig as much space to wander around in. But at least it's physically possible to take all 120 feet of fence and just lay it out horizontally along the river. There's no area, so it's probably not going to be the answer, but at least it's possible. So we'll say that 0 is the smallest value of x. Now, for the largest value of x, you might say that there's 120 feet of fence, so certainly x must have a maximum possible value of 120. The problem is if I use up all my 120 feet of fence running it along this side, a length of x, then I can't build the right side of the pen. So I have to be able to get there and back with the length of fence. If, let's say, I chose 61 feet of fence, then I would need 122 feet to get there and back. You can see the only number it makes sense to say the maximum of x is 60. That's the that's a number that's small enough, just barely small enough, that we could get there and back to the river with 60 feet of fence. And again, that would be a pen that's so skinny that it has no area, so it's not going to be the correct answer. But at the very least, that's at least it's possible to build a pen if we choose x as 60. So the domain of the function, the feasible domain, is 60. Now what we do is we just optimize. We're just going to optimize a of x on the interval 0, 60. So, okay. So what we want to do is we're going to find a prime of x. A prime of x using, I'll use this form of a of x. That gives me 120 minus 4x. A prime of x equals 0 implies that x equals 30. X equals 30 is going to make 120 minus 4x equal to 0, because 4 times 30 is 120. Clearly there's no place where a prime of x is undefined, so we can say is that the critical point is x equals 30. So now I'm going to evaluate a at the two endpoints of the domain and at the critical point. So a of 0 is going to equal 0 times 120 minus 2 times 0, which is 0. That's what we predicted. In other words, if I choose x to be 0, I have a pen that has no area. So now we're going to evaluate a at the other endpoint, which is 60. That's going to be 60 times 120 minus 2 times 60. That gives us 60 times 120 minus 120, or 60 times 0, which is just 0. As we predicted, if we use up all our fence going vertically there and back without leaving any fence left over for our horizontal dimension, we're going to get an area of 0 again. So now let's just evaluate a of 30. That's going to be 30 times 120 minus 2 times 30. That gives us 30 times 120 minus 60 is 60, and that is going to give us 1,800 square feet of area. So it certainly seems that 1,800 square feet is a lot more space for the pig than 0, so that's our answer. So what we want is we want a pen constructed where the x dimension is 30 feet. Well, we also know that we're being asked what the dimensions length by width are, and we can see that the width is going to be 120 minus 2x. So that means that if I take 120 minus 2x, I get 120 minus 2 times 30, which gives me 60. So the answer is that the dimension is that it is a 30 feet by 60 feet pen. That's what the farmer should build.